All right, thank you very much. I appreciate that. Wow. So I got to say that I'm extremely disappointed going at the tail end of this. I had really sort of hoped that the previous presenters would drop the ball, basically, and that I could just sort of coast in here and be sort of all I had to do was an adequate job and it would work out. But unfortunately, everybody did a fantastic job, and that makes me very, very sad right now. But that's okay. I'll work through that. So everyone who's still on the call, thank you so much for being here. So the previous presenters presented some absolutely fascinating areas of research that they're working on. I mean, that's killer stuff. I'm really impressed. And I have absolutely nothing to compete with them. All right, so I'm Dr. Jim Anderson. I'm an instructor here at USF, and I do have a particular area that I focus on for my research. I'm interested in artificial intelligence, and specifically I'm interested in a branch of artificial intelligence called deep learning. And basically, it gives you the ability to, in software, create neural networks that can be fed unstructured data and unlabeled data. Basically, it allows the system to be almost sort of self-learning. Not that it matters that much, but I'm specifically interested in applying my deep learning work towards horse racing, because what I'd like to be able to do is create a software system that allows me to predict the winner of a horse race before it's run. Now, the other researchers are going to produce fabulous and wonderful research that will undoubtedly make the world a better place, and I think that is fabulous and wonderful, and they have my full support. My research will probably make me a wealthy person if I can pull it off, so that's not quite the same, but hey, we all have to have goals, right? So I have a few moments here to talk to you today, and what I wanted to talk to you today is, instead of talking about an area of research, what I prefer to do is talk about you. So welcome to the Department of Computer Science. Fantastic and welcome. You're in the right place. So let's go with that. So if you're part of the Department of Computer Science, why are you here? Undoubtedly, you're probably thinking, wow, I'd like to attend USF. I'd like to go through the courses. And at the end, I'd like to pop out and be perhaps a software engineer. Well, that's great, but maybe you and I should have a discussion about what that actually means. And maybe, like, what do software engineers actually do? Now, you've got a lot of different options here at USF, and you've obviously signed up, probably, for at least one of them, and that's great. But an interesting question I'd pose to you is, did you pick the right area for you? I mean, there's 4 of them. Did you get the right one? So perhaps in my presentation today, we'll be able to explore what the 4 different areas are, and you can at least consider whether or not you're in the right area, or maybe one of the other areas would be a better fit for you. Sound like a fair deal? Fantastic. So who am I? So I'm Dr. Jim Anderson, and I teach a lot of courses here at USF. And why do I get to do that? Well, because a very, very long time ago, I went to university and I got a Bachelor of Science degree in computer science. And it was so fun. I had such a great time. I went back and got a master's degree in computer science. Not done then. I went back eventually and got a PhD in computer science. And arguably, that's where most people stop. And it certainly seems a reasonable place to stop. But I found myself out working in the business world, and people were using terms and terminology that I didn't fully understand. And since I was really good at going to school, I went back and got an MBA. So if you and I are ever in the same room and you wonder who the smartest person in the room is, I think you know the answer to that question. Now, after I got done going to school, I went out and got a job, and I didn't just get a job. I got job after job after job. I have worked for over 14 different companies during my career, so I know a great deal about working because I've done a lot of it during my career. So when I talk about what it means to be a software engineer, I know because I've been a software engineer. All right, let's talk about you for a moment, okay? So here's an interesting question. How long do you plan on working? Well, roughly at this stage of your life, what have you accomplished so far? Let us give you some credit. You went to high school, right? High school takes 4 years, right? So you started high school, you went there for 4 years, and with a little luck, you graduated. Congratulations, major accomplishment. As you well know, not everybody does that. Now, what are you preparing to do? Well, I'm going to go to college. So great. So you're in college, fabulous and wonderful. College takes how long? Well, we're hoping 4 years. It could be 5, 6, 7, whatever. And so basically, roughly four-ish years. No problems whatsoever. Bam! You pop out the other side of college, and you've got a degree. Congratulations! That's a significant accomplishment. Now you're going to go to work. Fantastic. So you will work. We know how this game plays out. You'll work. Someday you will retire. Fabulous. You get, let's just say, roughly about 20 years of retirement, and then you die, because that happens to everybody. Fantastic. So how long are you going to work? Well, for as long as I can. Well, let's think this through, okay? When do people retire? Well, generally it's when they can start to collect Social Security, right? And they keep changing the rules on that. So I don't know exactly when you can collect Social Security, like 65-ish, maybe? I don't know, maybe it's getting a little bit later, maybe 70-ish or something like that. Here's the scoop. Your working career is going to be roughly 45 years. You will work for 45 years. Now, arguably, that's the longest period of time you're going to spend in your entire life. Look, you spent 4 years going to high school, 4 years going to college, and then bam, 45 years working, okay? So if you're going to work for that length of time, let's make sure that when you pop out of college, you're set up to work for 45 years. Let's make sure that you've chosen the correct major for you. Because goodness gracious, 45 years seems like a really, really, really long time, doesn't it? Let's just make sure you're on the right path. Fantastic. Here at USF, how are you going to be able to pick that right path? Well, you're going to take required courses. I think I counted this up last night. I think there's like about 12 required courses specifically in the computer science program. Okay? What we need to understand is that if you want to become a software engineer, software engineering is not about programming. Yeah, programming's part of it, but that's not the whole story, okay? But it is all about what you're going to do during the rest of your life. So we should probably talk about what the heck else software engineers actually do. Well, here's a quick snapshot. They went out and they talked to a bunch of software engineers and said, what do you do with your time? And the one I want to point out here is the big blue bar. The big blue bar is the amount of time software engineers spend programming. And it came out to be about 20% of their time. I mean, if you're working 40 hours a week, that's what, I don't know, maybe like 18 hours a week or something like that. So it's roughly half their time is spent programming. That means they're spending the other half doing something else. Administrative tasks, environment management, waiting for things to compile or complete, and then brainstorming and collaboration with peers. So really, if you're a software engineer, yeah, programming's part of it, but goodness gracious, programming's less than half of what you're going to be spending your time doing. And I think that's an important realization to have. Congratulations, you know Java, you know C++, you know C#, you know C, you know perhaps Python because it's a great language. Not a problem. That's a good skill to have. That's a good tool to have. But that's not enough to be a successful software engineer. Okay? It's important, but it's only part of the whole program. All right. So you're here at USF and you're part of the computer science department. What can the computer science department give you? Well, it turns out there's 4 different things it can give you. It could give you a degree in computer science, if that's what you wanted. It could give you a degree in computer engineering, if it turns out that that's what you wanted. Alternatively, it could give you a degree in information technology. And if none of those met your needs, good news, there's one more option. A degree in cybersecurity. Now, what's important for you to realize is this is 4 different degrees. Depending on which degree you select, your life will probably go in a different direction. So really, you want to match your interests in what you want to do now and your interests in what you want to do in the future to which degree you get. So is it an important decision? It is. So the key thing is that you understand what you really want to do and make sure you get the right degree for you. All right, so what's the difference between the different CSE programs? Well, I did probably what you should have done before coming to USF. So I'm covering your butt on this one, okay? So I took a look at the 4 different degree programs and I said, what classes in these programs are unique? What classes can only computer science people take or only computer engineering people take that the other ones can't take? Because it seemed like a good thing to do. It turns out that most of the computer science classes can be taken by the computer engineering folks, no problem whatsoever. There's a bunch of computer engineering classes that arguably the computer science guys probably can't take, and they're all the hardware ones, right? Information technology and cybersecurity are really pretty closely tied together. There's a few differences, specifically cybersecurity has some special courses, obviously, on what else, but security related stuff. Information technology has some more stuff on like cloud computing and things like that, but really they're pretty close. There's not an awful lot of difference. So you're sort of splitting hairs between those 2 separate ones. There's a lot of electives and those they allow you to customize your program, but these show the specific classes that you'll be taking for each one of them. And you can sort of see the connections between them. Obviously, a great deal of connections between computer science and computer engineering, and a great deal of connections between information technology and cybersecurity. So it's important that you understand what courses make up each one of the degrees. So depending on which degree you get, you'll go out and you will do different things. So if you got a computer science degree from USF, what would you do? Who would you work for? And it's a good question. You could go to work for Facebook. You could go to work for LinkedIn because they do software and you'd be doing software. Bank of America, Tico Energy, City of Tampa, Nielsen, Chase Bank, Special Forces. Those are all software jobs, okay? Charter, Time Warner, Bright House. Once again, you would be writing code for these companies because they run their businesses based on software packages. Computer science graduates go to work for companies like this. Okay, that's great for computer science. What happens if I get a computer engineering degree? Great question. There's an answer for that too. So computer engineering means that you're sort of interested in the marriage between software and hardware. Tesla would be a great company to go for, right? They make a car that has a lot of sensors. Hamilton Medical, they make ventilation systems, okay? Amazon's Alexa division, the Ring doorbell people, the Nest home temperature folks, Instapots, or an elevator company. Those are all examples of companies that are software based, but their software only works when it works with a piece of hardware, which is sort of the computer engineering branch of the world. Okay. What happens if I get an IT job? Good question. So information technology graduates can sort of go to work for anybody they want. And the reason is because anybody who creates software has a team of software developers who crank out software. But that's not enough to start to use the software. Instead, what has to happen next is that software has to be translated through a DevOps or development operations set of tasks. It has to be tested, it has to be deployed, and it has to be maintained. And when you deploy it that way, you can get it into production. The IT graduates are the folks who will be doing the DevOps tasks. They'll take it from the software developers, ensure the quality of the software, and then they'll make sure that it gets out into production. So the DevOps guys won't necessarily be writing a lot of software. They will potentially write some software, but they won't be creating large programs. But they will be using an enormous collection of machines, of different applications to accomplish their jobs. So they're completely buried in software. All right, so that's good for the IT guys. What about the cybersecurity guys? Cybersecurity guys break into 2 parts. They're tasked 2 parts. The first one is they protect the organization that they're working for. And they do that in a lot of different ways. They set up firewalls, they ensure that everybody's using their passwords, they create whitelists, and so on and so on. That's protecting. If there's an incident, they will then investigate it. They'll take a look for breaches, any sort of tampering, any sort of phishing attacks, and so on and so on. So their life sort of breaks into two parts: protection and investigation. All right. So which program is right for you? You've got 4 to choose from. Good question. This is my son. He currently attends University of North Florida. Okay, he was enrolled in their computer science program during his freshman year. He took a class in C and he took a class in Java. And then he came home for the summer. And his dad said, "Hey, so you know C, you know Java. How about you sit down and write me a program in C?" And he said, "Sorry, Dad, I don't know how to do that." And I was like, "What up? You took the class. Didn't you know how to program in C?" And he said, "Well, I could recognize C. I could recognize Java code, but I couldn't just sit down and crank out a code because I just wasn't that interested in coding." And I was like, "Oh, okay." And it took me a while to wrap my head around this. For my son, computer science was the wrong major for him to pursue. Now, what's sort of interesting is, surprise, surprise, male boy, he enjoys playing online video games. And he was extremely upset with the desktop unit he was using because, in his words, it was too slow. So what did he do? Went on Amazon, selected a whole bunch of parts, had them delivered to the house, and he built himself a new gaming rig. And he had a blast doing it. Doesn't take a rocket science to start to go, "Oh, hey, you're more of an information technology guy, right?" And the answer is yes. So my son switched his major from computer science to IT because that's truly what he's interested in. And I think that's an important distinction. If he'd popped out of college with a computer science degree and the ability to do programming, he would not have been a happy camper. That would be not what he wanted to do. So it's much better that he find the right career for him and make sure that he pursue the right degree. He's going to have a much better time in information technology. So it's just something for you to consider to make sure that you're in the right degree program. So if we talk about how software is created traditionally for like the last 40 years or so, it's been created using something that's called the waterfall design process, where people go out and meet with customers, get some requirements. They use it to create a design that gets handed off to a software development team. After the software is created, it gets tested and deployed. This was a great way of creating software, and we did it for about 40 years. There's some huge problems with it. And basically, the fundamental problem is it takes too long. It can take up to a year to develop a piece of software. And during that year, your customer who you talked to at the beginning of the year, things changed. And what they really want to have is completely different at the end of the year. You deliver software to them that no longer meets their needs. What happened is they created a brand new way to create software called Agile software development. And it's all the rage right now. You have a ton of things that the customer would like you to do. It's called the product backlog. Do all of these things for us. You can't do all of the things. That's too much work for anybody to do. So what you do is you carve part of it out. It's called a sprint backlog. It's a few features. And then what you do is you have something called a sprint, which is basically 2 weeks. In 2 weeks, I will implement a collection of features. And when it's done, I will show it to you. And you will go, "Yeah, that's what I want." Or I'll show it to you and you'll go, "Oh, now that I see what you've done, I know what I want." And it's not that. So Agile software development allows you to have a lot more conversations with your customers, deliver software to them, and get feedback from them. It's the new way of developing software that everybody's doing right now. In order to get that software, once it's developed, out into production, the IT folks have to do something called DevOps, which is development operations. And it consists of basically 8 different steps, right? So basically what happens is you go ahead and you build it. Then you have to test it, you release it, you deploy it, you operate it. While it's out in production, you monitor it. Based on what you see, you do some planning, and you go back and you have people doing coding. As you can see from the image on the screen, there are a ton of different software packages that you can use to automate the DevOps process. And that's the golden secret for pretty much every company out there. What they would love to have happen is to have their software developers get done coding and have that code automatically flow through all 8 steps of that DevOps process and poof, end up being automatically deployed to production hands-free. Can that be done? It can be done, but it takes the work of a lot of very talented IT people to configure each one of those systems to allow that to happen. And it doesn't really happen at very many companies because it's so complex, okay? But you can see that the IT folks don't necessarily do programming, but they have to configure all of those different packages to work correctly. So it's a form of coding. They're not creating brand new programs, but they are certainly using programs that are out there. All right, to sort of wrap up my discussion with you today, I want to present a real world problem to you. I call this the Tesla Model Y programming. And on your screen right now, you see a picture of the fabulous new dashboard for the Tesla Model Y. Man, that is one cool car. But you know, just looking at that dashboard, there's a lot going on there. The Tesla has an entertainment system. It has software that's doing battery monitoring, navigation, collision avoidance, software updates, climate control, getting updates to the navigation system, power management, security, and the charging systems. Okay? There's a lot going on there. There's a ton of software in a Tesla Model Y. Interesting question for you. Which USF grads would produce what part of that? Well, let's take a look. Entertainment could be created by the computer science guys because it's really just software, right? I'd say same thing with navigation. You're just doing stuff with software. Software updates is clearly software. Navigation updates, once again, that's primarily a software task. And I'll even say finding the next closest charging station is a software task. So I can use computer science folks for that. Now, Tesla has a lot of different systems. There's a lot of software that talks to those systems. For those other systems, I'm going to have to find the computer engineering guys. They're going to have to do battery monitoring, collision avoidance, climate control, and power management, and probably security also, right? So really, what's interesting here is that from the graduates from USF, they sort of have to work together to get a Tesla Model Y to work correctly. But stop, that's not all. Creating the software is fine, but getting it into the car requires more effort. Okay, so at Tesla, they have a complete software deployment system, right? So the software development is pretty much the computer science guys, the computer engineering guys, and probably also the security guys, right? Because Tesla wants to make sure that the software that goes into their cars is secure. Who better to do that than the cybersecurity folks? They got to be involved in that. Once the software has been created, it's got to be moved over so it can be deployed in the cars. The DevOps guys are going to be involved in that. They'll take it, they'll test it, they'll package it, and they'll push it to production. That's an IT job all the way. Once it gets to production, making sure that in production it works correctly, the IT guys are going to have to work on that. And once again, the security guys get involved to make sure that a Tesla Model Y is actually a secure system. So the takeaway from all of this is to understand at USF we offer 4 separate degrees, okay? Each one of them positions you to go off and have a 45-year career doing completely different things. And at this stage of your career, early on in your college experience, it would be well worth your time to sit back and spend a little bit of time thinking, what do I really want to do for the next 45 years? Do I just want to create software? Do I want to get software to talk to hardware? Am I not really a programming person, but I like computers? Am I more of an IT person? Or do I want to find ways to secure computers from people doing bad things to them? You know, the answer to those questions can be whatever works for you. There's no right answer. There's no wrong answer. But what's most important for you at this point in time is that you take the time to think through it and come up with your answers, because it'll help you make the right decision for you, which is important for the next 45 years. All right, that's the end of my presentation today. There's no possible way anybody can have any questions for me, but I'll ask anyway. Are there any questions?
You did have a few questions in the chat come up when you were describing the different teams between the Tesla Y model. So students want to know if you were talking about a specific kind of security, hardware security, or the security of the car.
Gotcha. Well, no problem. And that's a very good question. So let's think about it. So let's just say you work for Tesla and you have to figure out security for their products, which is their cars, right? Where are you going to put security? Well, you got a lot of different things going on. You don't really want drivers tampering with the software systems in the car, okay? So fundamentally, you've got ports all over that car for maintenance and stuff like that. You need to make sure that somebody doesn't show up, plug something in, and then suddenly gain access to the software, the systems. You also have to make sure that somebody walking by on the street can't cause the car to trigger and unlock itself, right? I believe those Teslas have a remote control key fob that just recognizes that their owner's there and then unlocks for them. So you need to make sure that only the owner can get into the car, right? Teslas, all of them, also receive software updates over the air, right? Through like the cellular network. So that's a huge security hole. You have to make sure that somebody doesn't send a Trojan software update to a Tesla that would get installed and then potentially take control of the car, right? So you need to secure that. So you have to physically secure the car, you have to secure the updates, and then back at Tesla headquarters, you know, that Tesla software is worth millions, billions. If somebody could get a copy of that and run off to some factory in China and start cranking out knockoff Teslas, they'd be king of the hill, right? You have to secure all the Tesla systems back at Tesla HQ, which is an entirely different type of security task. So you have to secure the product and you have to secure the company, and that's all security.